Hello to everyone. In this video, let us discuss what are zero order reactions and characteristics of them, and also regarding first order kinetics. Okay, see here first, zero order reactions. What is the meaning here? The reactions in which rate is independent on concentration terms of reactants. That type of reactions are said to be, which one here? Zero order reactions. The reactions in which rate is independent of concentration of reactants, that reactions are known as zero order reactions. Now, what are the examples of zero order reactions? First one is which one? Photosynthesis. Photosynthesis reaction is independent on concentration of CO2 and water. And second example here, photochemical reaction in between H2 and Cl2. Second example is what here? Photochemical reaction of H2 and Cl2. And another one here, decomposition of N2O on which one? Hot platinum surface. Decomposition of which one? N2O. On which one here? Hot platinum surface. This is another example. And another one, decomposition of ammonia in presence of which one here? Molybdenum. And similarly, decomposition of H2S on gold surface. And another one, iodination of acetone in presence of H plus ions. So these are the examples of which one means zero order reactions. Okay, then let us go for here. And what is that rate constant expression for zero order reactions? So how to determine that rate constant expression? See here first. For example, if you consider any one reaction, A gives products. Of course, for this zero order kinetics, rate equals to K into A to the power 0, because this is which kinetics? Zero order kinetics. A power 0 means we know that which one? 1. That means now we can write here dx by dt equals to K, and upon integration we can get x equals to kt. That means K is equals to x by t. So this is the rate constant expression for which one here? Zero order reactions. Now let us see what is here, that characteristics of zero order kinetics. So what are the characteristics means here? Concentration decreases linearly with increase of time. That means here this is having negative slope, that is which one? Minus k. And here at equals to, we can write what the expression? A naught minus kt. So that means here at means concentration of reactant at t time. A naught means concentration of reactant at initial time. So this is initial concentration. So like this, concentration of reactant decreases linearly with increase of time. And what is another important thing here? Time of completion. What is that meaning of time of completion? The time at which initial concentration is equal to 0, that time is known as time of completion. So for zero order reactions, time of completion can be written as time of completion equals to A naught by K. So that this is the expression for the time of completion. And T half, that means half life period. What is the meaning of half life period? Let us see here. The concentration of reactant, after some time it will become how much? Half of that value. So that time required for the initial concentration to become half of its value is known as which one means half-life time or half-life period. So now this is the time of completion. If it is a time of completion, then what should be the which one here? That value t half equals to, we can write which one here, a naught by 2k. So that means by using this expression we come to know one thing, for especially for zero order reactions, half life period is directly proportional to initial concentration. If initial concentration become halves, half life time also become halves. That means 100 gram of initial amount of substance, for example in 2 hours it became 50 grams, means the time required for the initial concentration, the time required for the change of 50 grams to 25 is how many hours, means 1 hour, because half life time is directly proportional to initial concentration. When initial concentration 100 grams, half life of this zero order reaction is which one? 2 hours. And here if after that initial concentration is 50 grams, half life period of zero order of that zero order reaction is how much, means 1 hour. So like that here half life time is directly proportional to initial concentration. So these are the characteristic properties regarding which one means that zero order kinetics. And then if we plot a graph in between T of and A, so as initial concentration increases, T of value also increases. So this is the graph related to which one here, T of and initial concentration. This is for zero order reactions only. Okay, now let us go for which one here, first order reactions. So what is a first order reaction? A reaction is said to be first order. How we can say that? If the rate of reaction is, now that is measured by changing one concentration term. That means if the rate of reaction is depends on only one concentration term, the type of reactions are called first order reactions. Now examples for first order kinetics, what are here? Decomposition of H2O2. H2O2 decomposition will come under which one? First order kinetics. And the second example is here, hydrolysis of ester in presence of mineral acids. In presence of mineral acids. And third example, inversion of cane sugar. So these are some examples for which one? First order kinetics or first order reactions. Okay, now let us see the derivation of rate constant for a first order reaction. So how to determine that rate constant? See here. For example, A gives products and initial concentration is A and products 0. After T time, some X amount of reactant converted into products. So the remaining concentration is how much here? A minus of X. Now here dx by dt equals to k into A minus of X to the power 1, because it is a first order kinetics. And upon rearrangement, dx by A minus of X, okay, let us write here dx by A minus of X equals to k into dt. So upon integration on both sides, so what we can get here? Minus log base e A minus of X equals to kt plus c. So this is base e, not base 10 logarithm. And here at t equal to 0, at time t equal to 0, what we can get here? X equal to 0, because at initial time that product is not yet formed. By substituting these values in this expression, what we can get now, C equals to minus log base E A. By substituting t equal to 0, x equal to 0, we get this expression. By substituting this C value in this first equation, now what we can get now, minus log base E a minus of x equals to kt minus log base ea, and minus log base ea when that bring to this left side, what we can get now, log base e a by a minus of x equals to kt, and by multiplying with 2.303, base e logarithm can be changed into base 10, and by that we can get k equals to 1 by, okay, now we can write that k equals to 2.303 by t log a by a minus of x. So this is the rate constant expression for which one, first order kinetics. K equals to 2.303 by t log a by a minus of x. A means initial concentration, a minus of x is concentration at t time. So this is the rate constant expression for which one, first order kinetics. Okay, then let us see what is half lifetime expression for first order reactions. Half lifetime. So now let us consider this. T of equals to, we can write the expression 2.303 by k log a by a minus of x. This is time expression. But T of equals to, what we can change here, 2.303 by k log a is common, a minus of x means half-life time, means that initial concentration become half, so that we can get a minus of a by 2. So we can write that as a minus a by 2 in place of x. Therefore t half equals to 2.303 by t. What we can get here, log a by 2. A and a get cancelled. T half equals to, okay, t half equals to 2.303 by k. Now here we can get log 2, and upon calculation t of equals to 0.693 by k. This is the half lifetime expression for which one, first order kinetics. And upon observation we come to know one thing, for first order kinetics, half lifetime is independent on initial concentration, because in this no initial concentration term. So independent means what is that meaning? Okay, let us see one example here. What is that? First example, for a one example I will give here. Half life period is 2 hours for 500 gram, or we can take it is which one, 600 gram, 600 gram of substance A. If it is follows first order kinetics, therefore what is that amount of the substance remaining after 2 hours, let us see here. So now 600 grams in 2 hours, as it is half life period, 600 grams will become 300. In another 2 hours, this 300 grams will become 150. In another 2 hours, this will become 75 grams. That means here half life period is independent on initial concentration. Whether the initial concentration is 600 or 300 or 150, here for the same substance, half life time remained constant. So this is regarding which one here, half life time of first order kinetics. And then let us see average lifetime. So what is average lifetime here? Average lifetime means the time required for the reactant. That means the time required for the completion of 63.21% of reactant into which one product. The time required for the conversion of 63.21% of reactant into product is known as average lifetime. And average lifetime is inverse, and that means reciprocal to which one? Rate constant, or we can write here 1.44 into T of. So this is the expression useful to calculate which one here? Half life, that sorry, average lifetime of which one? That first order kinetics. So in this first order kinetics, let us take some important relations. So what are the important relations? Means the first one is average lifetime equals to 1.44 into T of, and the second one is here T 75% equals to 2 into T 50%, and third one T 87.5% equals to 3 into T 50%, T 93.75% equals to 4 into T 50%. And another some examples we can give. Amount of substance remaining, amount of substance remaining after 1 T of, one half lifetime. Formula is initial concentration by 2 power 1, and amount of substance remaining after 2 half life periods, A by 2 power 2, and amount of the substance remaining after n half life periods, initial concentration by 2 power n. So this is the which one here? Amount of the substance remaining after n half life times initial concentration by 2 power n. That means after that 3 half life periods, if they have given A by 2 power 3, after 4 half life periods, amount of the substance remaining how much? Means A by 2 power n, and n is what here? Number of half life periods. How to determine that n value? N value equals to the total time given, the total time given by half life period. By that what we can get here? Number of half life periods. Okay, and some other relations also there, we can write those relations. See here, what are the remaining relations? Means the relation between T 99.9% and T 50%, and T 50% with T 90%, etc. Okay, let us see what are the relations here. T 99.9% equals to, relation is 10 into T 50%, and then T 90% equals to 10 by 3 into T 50%, and another relation T 99% equals to 2 into T 90%. T 99.9% equals to 3 into 90%. T 99.9% equals to 4 into T 90%. That means within one equation we can write this: T 90% is to T 99.99% is to T 99.9% is to T 99.99% ratio 1 is to 2 is to 3 is to 4. So these are some important relations regarding which one means that first order kinetics. These are the some important. Okay, now what are the questions we get regarding these relations? Let us see here. The first question is half-life of a first order kinetics. Half-life period of a first order kinetics is 2 hours. What is the time required for the completion of 75% of reaction? So what is the relation between T 75% and T 50%? 2 into T 50%. So 2 into T 50% means we have to write 2 into 2 hours means the time required for the completion of 75% of the reaction is how much means here 4 hours. So this is one question regarding that. And then another question, let us see here what is that. Another question, T 90% of a first order kinetics is 1 hour. What is the time required for T 99.9% of the reaction? So we have to consider the relation between these two factors only. T 90% is to T 99% is to T 99.9. If you write up to here, what is the relation? 1 is to 2 is to 3. But the question related to T 90% and T 99.9%. So T 90% by T 99.9% equals to 1 and 3. Only we have to consider that ratio. Now what is that given here? T 90% to 1 hour. So 1 by T 99.9% equals to 1 by 3. T 99.9% equals to how much time it will takes place means 3 hours time. So like that. But the same question if they may give in another way. What is that another? See here. What is that means? For example, T 99% of a reaction is, so of course they may give here 2 hours. What is the time required for T 99.99% of the reaction? So when this type of questions are given, first let us calculate T 90% of the time using this 99%. Then only convert this 90% to 99.99%. It is easy. So what is the relation between 90% and 99%? T 90% is to T 99% equals to ratio, we know that 1 is to 2. So let us calculate 90% first. So T 90% by T 99% time we have given 2 hours. So 2 equals to 1 by 2. Therefore T 90% equals to 1 hour. Now 90% time we have to convert to which one? 99.99%. So what is the relation between that? T 90% is to T 99.99% ratio 1 is to 4. That means if 90% is 1 hour means 99.9% will become how much time means that 4 hours. So like that, by using these ratios we have to calculate, by knowing that T 90% we have to calculate other percentages etc. Okay, this is regarding that. Okay, then some other questions also they may give regarding which one here, that average lifetime. Average lifetime means what they can give here? They give half-life period. We have to calculate average life. So what is the relation between average life and half-life? Average life equals to 1.44 into T 50%. So if half-life time is 10 hours, so what is its average lifetime? Means 1.44 into 10 hours means we can get 14.4 hours. So this is the calculation of which one means here average lifetime. So these are the questions related to which one here first order kinetics. Okay, then after this in our next video let us go for second order and third order examples, and then collision theory of reaction rates. Okay, bye.